So we're going to look at counting techniques now. And so we're just going to start out with several examples, and we're going to work our way into what are called permutations and combinations. So these first several examples are going to lead us into that. And so first, go ahead and pause the video and write this problem down. And I encourage you to try to work it yourself and then come back and see what I'm doing here. So I'm going to read it. Example 1. Suppose you're at a restaurant and you have to choose one entree. Those choices are steak, fish, or chicken, and one side, potatoes or beans. How many different meals can you have or can you choose? So let's do it something like this. Let's say, so we have a choice of, let's write all our choices out here just so we can see where everything's coming from. Let's start with the entrees. We have steak, fish, I'm going to give myself a little room here, and chicken. And then so once I choose one of these, then I have two options. Say I choose steak, then I can choose between potato or beans. And then with each of these entrees, I have those same options. So fish, I have potatoes or beans, and I'm just going to label as P and B now. And then same thing with chicken. I have the choice between potatoes or beans. And you can see here that if we just add all these up, we get 6. You can have steak with potato, steak with beans. Those are 2 options. Or fish with potato, fish with beans. That's 2 more options. Or chicken with potatoes and chicken with beans. That's 6 options. So how did we get there? So we had 3 entrees. So that's 3, and then 2 sides to choose between. So times 2, which is equal to 6. All right. So pretty straightforward there. Let's look at another example and go ahead and pause the video, write this down, and try to work it yourself and see what you get. And then come back and see what I've got. Example 2. Suppose your license plate consists of 6 characters, 3 numbers 0 through 9, and 3 letters A through Z. How many unique license plates are possible? So let's do it like this. So we know we have 6 spots available. So let's go ahead and draw 6 spots like this. 1, 2, 3, 4, 5, and 6. And so in this first, let's take care of these first 3, which are numbers. In this first spot, how many numbers can I choose from? Well, 0 through 9 means those are 10 numbers. So I can choose between 10 numbers here. Let's move on to the next spot. How many numbers can I choose from here? Same thing, 0 through 9, which are 10. And then the last spot for numbers is 10. So that covers the numbers. Now let's move on to the letters. How many letters can I choose from at this spot? 26. Then how many letters can I choose at this spot? 26. And then the last spot is 26. So the way you would find your answer is you multiply all these together. So you get 10 times 10 times 10 times 26 times 26 times 26. Multiply all this together and you will get 17,567,000 license plates. All right, hopefully we're following so far, and we're going to move on to another example here. All right, same thing. Pause the video and write this down. Try yourself. Example 3. You have 5 items to scan at the grocery store. How many ways can you scan the 5 items? Let's do the same exact thing we just did. We know we have 5 spots available. 1, 2, 3, 4, 5. All right. So this is our first item we're going to scan. How many possible items are there that we can scan? Well, there's 5. We haven't scanned anything yet, so 5. And then we scan the first item. How many items are left to scan? 4. So we can scan any one of those 4. Then how many items are left to scan? 3. Then 2, and then 1. So same thing. You multiply all these together. 5 times 4 times 3 times 2 times 1. And here you'll get 120. All right. So I want to talk more about what I just did here to get this answer. Notice that these are consecutive numbers all multiplied together. And we're going to be doing this so much that there's a special notation that we use for this, and it's called factorial. And we'll be using factorial a lot from now on. Factorial, in general terms, if you have n factorial, that's equal to n, and then you multiply that number by n minus 1, just subtracting the number by 1, and then you multiply by n minus 2, and so on. You keep multiplying until you get all the way to 1. So 3 times 2 times 1. All right, I know that looks a little funny like that, but let's look at a specific example that may help you, that will help you understand what's going on there. So let's take this example that we just did in 3. So let's say I have 5 factorial. All that's saying is you take all the numbers less than this number and you multiply them together. So we start with 5, and then we multiply all the numbers less than 5. So 4 times 3 times 2 times 1 is 120. And that's all factorial is doing. You can have 100 factorial, which is really large. You could have, so just as another example, 2 factorial. You start with whatever that number is, 2, and then you multiply all the numbers less than 2 together, and then times 1, which is 2. There are some special cases. So 1 factorial, that's just 1. And then 0 factorial is also 1. So we'll be using this quite a bit. Just make sure you're comfortable with factorial. You'll see this again here momentarily. All right, example 4. Pause the video, write it down, and try to do it yourself. So, how many ways can horses in a 10-horse race finish first, second, and third? All right, so start out exactly the same way that we've been doing. We have 3 spots available, or 3 spots that we care about. And let's say this is first, second, and third. So how many horses can finish first? 10. Any of the 10 can finish first. So someone finishes first. How many are left to finish second? 9. Then how many are left to finish third? 8. And that's all we care about here in this example. So you multiply these together, 10 times 9 times 8, and you get 720. All right. So this is where one of the terms I mentioned at the beginning is coming into play. It's called permutations. So let's write this. This is called a permutation. Because my pen is running out. I'm going to change colors real quick. Permutation because the order in which the horses finish the race is important. And that's going to be a distinction there. When we're dealing with permutations, the order is important. So think about this in a race. If we care who finishes first, because first means more than second, and second means more than third. So order is important here, and we care about that. So we need to get into the definition and the formula of permutation. So permutation, a permutation is given by, and you may want to watch me the first time we write it, is given by, watch me real quick, little n with a capital P and an R. So that's how we represent that we're dealing with a permutation. And that's equal to, and keep watching, so we have a divide sign here. On the top we have n factorial, there's those factorials again. And then on the bottom we divide by n minus r factorial. So there are some key things here to note. We need to know what r and we need to know what n and r are doing here, or what they are in this case. So n is the number of distinct objects. R is the number of objects chosen. And so these two bullet points are going to be the exact same when we get to combinations in the next video. The third bullet here is the important one. And here, order is important. All right, so let's try this formula on example 4 again. So example 4, oh yeah, that pen is not working. I remember that. So let's do example 4 again, but this time we're going to use the formula. Example 4, using formula. All right. So write our formula. It's NPR is equal to n factorial divided by n minus r factorial. And here, n is the number of distinct objects. So n would equal 10. We have 10 horses in this race. And then r is the number of objects chosen. We cared about first, second, and third, so there are 3 objects. So that means now anywhere there's an n, we can replace it with 10. And anywhere there's an r, we can replace it with 3. So we say 10p3 is equal to 10 factorial divided by 10 minus 3 factorial, which is equal to, just simplifying a little bit, 10 factorial divided by 7 factorial. So you just treat these, the parentheses are here because it tells you that's what you need to do first, so we subtract those. So if we were to write this out, I'm going to run out of room here. If we were to write this out, we would get 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. And you won't always have to write this out like that. You'll eventually learn how this is going on in your head. But since we're multiplying everything on top and bottom, and we have 7 times 6 all the way to 1, the same as on the top and bottom, these parts just cancel each other out. And all I'm left with is 10 times 9 times 8, which is equal to 10 times 9 times 8, which is equal to 720, which is exactly what we found up here when we worked it just by hand. So it's going to be important to learn these formulas, know this formula and the combination. It's nice to know how we got it up here, but we're going to get more involved later on, and these permutations will be helpful. So in the next video, we're going to learn about combinations, and we're going to learn how to tell the difference between a combination and a permutation.